Hello, everybody. So hold on, there we go. So this is going to be a pretty quick video here. This is going to be just another video to show you what to do for the programming assignment. Specifically, I want to make sure you know how to turn the assignment in and what files you need and that kind of stuff. So as soon as we talk about that, that'll be it for today. And yeah, you should definitely get started working on the programming assignment. So keep in mind that the programming assignment is due this Friday. So that's the 11th, I believe. So you don't have that much more time to do it. And yes, most of the assignment is just running the code that I gave you. There's very little code you have to write yourself. However, anything that you're doing on a computer where you're doing programming, you probably know this already, but everything takes, 5 times as long to do as you think it's actually going to take. So get started before Friday. Okay. If you don't, then on Friday, allocate a couple of hours to make sure you get it done. Of course, if you don't get it done on Friday, you can turn in stuff late in this class. So if you turned it in on Saturday, you'd still just get a 90%. If you turn it in next week, you'll get, a 75%. So yeah, try to get it in on time and try to give yourself enough time to do the assignment. Okay. Let's go ahead and get started here. So I'm looking at the Canvas website. It looks a little bit different for me because I'm not in student mode. Let's put it in student mode actually. So this should be exactly what you see if you log into the course website. Um, I don't have the week 4 stuff up here, so I have week 3. So I have programming 1 here. Of course, you get programming 1, you click on it. There's a PDF, which I've downloaded many times. I'll download it one more time. There it is. Opened it again. It's probably the same as this one. This is what you need to do. There's a zip file, which we talked about last time. You're going to need to unzip that file someplace. Well, do you? Yeah, I mean, I guess on this one, you don't really need to unzip it. But on most programming assignments, I'm going to give you some M files that you need. In this one, I don't think I did. So you don't actually need to unzip that for this assignment. And there's a video here, which is the first um, video to help you with the assignment. Okay, so this will be the second one that will help you. Now let's go ahead and get started. So I have the web browser open here because hopefully you remember that this is how I suggested you do your assignment by going to Overleaf, creating a new project, which you can create a project by uploading the zip file. Let me actually show a folder. So this zip file here, programming assignment number 1, if I look in it, it just has a plot, the tech file for the programming, and it has this file called mcode.sty. Those are the files that make up my PDF. So like this PDF right here that you're looking at came from the files in this folder, right? So these 3 files together made up this PDF, okay? And I made it with Overleaf, which is a LaTeX compiler basically. And LaTeX can be hard to get installed and working on a computer, and that's why I suggest that you use the online Overleaf. And you have to have an account, but accounts are free, and you can use like Gmail account or whatever as your login. So um, pretty easy. Now, I'll just go ahead and do this in a different way than I did in the previous video to show you that. So here, let me just put like my PDF stuff. Okay, so I just put this all in a folder here. Here it is, programming assignments, and I have my PDF stuff. So these are 3 files here are what I used to make that LaTeX document. If you open them up, you'd have to open them in some kind of text editor. I'm going to open them in Notepad++, which I happen to have installed. We have a lot of stuff here that we don't need. Oops, not what I'm trying to do here. Make small. Hold on. It's hard to navigate all these windows because I'm usually running my computer at 4K, and then I just set it to 1080p for the video, and now everything's weirdly sized. Um, so, of course, you look in here, it's just a text file, okay, with markup code. Now, in Overleaf here, in the web browser, once you're logged in, you can click New Project, and you can do Upload Project. So if you click Upload Project, it says select a zip file. Well, the zip file is going to be the zip file that you downloaded from Canvas if you want to do it that way. Okay. I did that last time, so look in the previous video if you want to see that. The other way you can do it is you can just say new project, and you can just do blank project. And so I'll do this, and I'll say, let's see, sample programming 1 or something. Okay. And so I created this sample programming 1, and it has like a tech file there ready, but this is not what I want my assignment to look like. And that's being generated from this main tech file here. We don't need that main tech file, so I'm just going to delete it. Okay, now there's no files here. But if I click this, I can upload files, and then I can drag them. So I can do them one at a time. If you miss one, you can come back and do it again. I'm just going to select these 3, drag them over. All right, now it doesn't know what my tech file is, so it says select file. I'll select it right there. Then I'll hit recompile. And assuming it has all the files you need, it will make a PDF, and that PDF will be exactly like the PDF that I gave you guys. Okay. Now, if you're missing this file here, mcode.sty, it will not make the PDF. You have to have the tech file, which is like the actual document, and then this mcode file is like a library, and that's what actually lets it put the nice boxes around MATLAB code. It lets it add color and syntax highlighting stuff. Okay, so that's why I have that mcode.sty file there. All right, now I'm going to drag this over here because I'm looking at the web browser in a really kind of small window here. Let's just make this big, actually. That'll be better. So you've got 100%. So you've got this here. We talked about this last time. The way you would edit this is you find where you need to be typing in here that would correspond to a place in here, and then that's where you can add your explanations for things. Also, another thing we talked about was when you wanted to run code from the PDF, never copy paste from the PDF. Like, I don't want to copy this code here and paste that into MATLAB because this is formatted text. It has all kinds of special characters and weird things in it, okay? And so it might look right, but then MATLAB will give you an error if you try to run it, okay? So if you copy paste, you would want to copy paste from here, from the actual text. So I'm going to copy all of those lines. I'm going to go into Octave here, using Octave instead of MATLAB today, because why not? And I'm just going to paste it all. And it just ran all of that code, right? And so we did this last time. So we were supposed to run these lines and then talk about what the code did. So the first one was t equals 1 to 3, and it made a vector 1 to 3. Then we had w equals 1, 2, 3, and it created a vector 1, 2, 3. When we did semicolons between numbers, it made a column vector. When we put commas in between the numbers, it makes a row. Actually, there's a lot of ways to make a row, aren't there? And when we put spaces, you would get a row, but this apostrophe here on the end, or tick mark, it makes it vertical. So like if I do this, 1, 2, 3, I'll do 4, 5. That's horizontal. But if I do 1, 2, 3, 4, 5 with a tick mark, the tick mark is shorthand for the transpose of a matrix. So it makes it vertical. Okay, so you can explain your results here. You say these lines make vectors, rows or columns. The columns, we used semicolons, or the tick mark to get columns. Spaces or commas give you row vectors. So just some kind of explanation. And I'm typing it right here because I can see that this is problem one, right? I can tell from the code here that this is problem one. So I typed this in, I hit recompile, and you'll see now it's got extra text here. And if I decide I don't want it to say explain the differences you see in the results, I can just delete that from right here. So I can go like my answer colon or something like that. However you want to, as long as I can find your answer, it's fine. So that's how I recommend that you do your PDF write-up, is just by editing mine. Okay. Now we talked about all this stuff last time, so I'm not going to go over all of this again. I'll remind you of the syntax for for loops and stuff and if statements. We didn't talk about if statements last time, so maybe I'll just give you an example of an if statement. So let's see here. Create a new script. My script's going to be very dumb. I'm just going to say, oh, one thing I do want to talk about, and it came up last time, was in, where are we? Problem 3. Oh yeah. So the code for displaying text on the screen, I was using printfs in Octave, and that doesn't run in Matlab. So the approved Matlab way to do it is what I'll do right here. So let's see here. So let me do this. So let me say just something really dumb here. N equals 4, right? And then I'm going to say if n equals 4, right? Equals, not equals. Same rules as Java here. If you use equals, it will assign 4 to n. You have to use equals for the test for equality. So if n equals 4, I want to display a message on the screen. So the way that you're supposed to do it in MATLAB is you actually make a variable like that, s equals, and you use this sprintf command. So what sprintf is it's string printf. And so that's a printf command that goes to a string variable. And the reason you have to do that is because apparently MATLAB doesn't let you just use printf to print to the, what's it called? To the command prompt. I don't know why, but this is how you're supposed to do it. So s equals printf, and then you can type what you want to print. And it's the same as a printf command in Java, or it should be. So let's see here. Yay. In was, I'm going to go %d, placeholder there, \n for a new line, comma, oh, we're not doing anything. Oh yeah, we are, in, comma, in. Okay, now, so that's how I start an if. Now, if I need to do an else, I would type else, probably make that line up with if there, and then I could, oh, actually, there's one more thing I have to do here. I will do it momentarily. Ooh. In was not 4. It is %d. Okay. And then I'm going to end this like so. Okay, so this is a dumb script, but I don't care. So I'm going to save it. So I just hit Control S. You can go to the editor here. and I'm going to call it dumb if script dot in. Okay, now actually, you know what? I'm going to take away this. Just going to have the if statement here. Run. So I got an error. I tried to run it, and it gave me an error because in was undefined, but I can define in right here. So what if I do in equals 1? Right, in is 1. Now I can run my dumb script. If I start typing a few words like dumb, and then I hit tab, it will try to complete my statement here. So I didn't have to type that myself. So dumb if script. What goes on the screen? Nothing. Okay, because I didn't print anything on the screen. Remember what I said about this? Sprintf prints to a string variable. So I've got this S and it's got words in it, but I never put that on the screen. If I wanted to put it on the screen, I would have to do a display S. And this is actually how you're supposed to do it in Matlab. One line to make it a string, and then a second line to actually put it up on the screen. Why? I do not know, but that's how it is. So if I run the script now, it'll actually display it. So I just press up, right? Up will cycle through your previous commands. So up once, run the script. Now this time it comes up on the screen. Boo, in was not 4, it is 1. What if I do in equals 4? Run the script again. Yay, in was 4. Okay, and so that's how you're going to do an if with an else, right? If, else, and then end. If statements, for loops, while loops, even functions all end with just end in MATLAB. All right. Now, what if I'm going to have some other things going on here? What if I do this? What if I go, if in is 1, do this. Yay, in was 1. I'm going to pick off that %d. We don't need that here. Yay, in was 1. Else, boo, in was not 4. Okay, I'm going to change that. But what else I want to change is, what if I have another command? Else if, like this, I can go in equals 2. I can say yay, in was 2. That should be an in, right? Capital N. I could do, let's do another one. Let's do a 3. So you can do, if you're doing else ifs, when you have multiple conditions, you can do as many of them as you want. And then when you're done, probably you should have an else. And an else would not have a condition on it. So this last one will say boo. Boo. So what do we have? 1, 2, 3 are special cases. And then I can say here in was not 1 to 3. Okay, so now I've got a more complicated if script here. So if I come here, if I go in equals 1, let's run the script. Yay, in was 1. Now if I go, oh, come on. In equals 2, run the script. Yay, in was 2. In equals 3, run the script. Yay, in equals 3. In equals 4, run the script. Boo, in was not 1 to 3, right? So it checked if in is 1. If it is, it does this first block. It checks if in is 2. If it is, it does this block. Checks if in is 3. If it is, it does this block. And then else means for everything else, it does this, right? Now what you could do is, if you didn't need it to say anything here, you don't actually have to have an else. You can leave the else off like this. And then you only have the 1, 2, 3 cases, and you don't have anything else. So that would be the same as before if you use a 1, 2, 3. If you do anything else, like 5, just says n equals 5. Oh, well, yeah, I didn't run the script. Okay, the script doesn't do anything, right? Because n equals 5 was not one of the 3 cases that I included. So this is the syntax that you would use for ifs when you have multiple things to test. And if you have a default case, what's your else? The main thing to keep in mind here is the way else if works. One word there, right? That's what's weird. Okay, now we are going to double check that this works in Matlab. Boo. Let's just say boo. We are going to check if this works in Matlab now. So let me switch to Matlab, which is somewhere. Here it is. Big. I still have my dumb if script in here. So in Matlab, let's do n equals 1. Let's try to run our script. So I'm going to start typing dumb. I'm going to hit tab. Again, it auto-completes. Enter. Yay, n was 1. So we used the correct syntax there for printing to the screen. Last time we had an error, and then I just fixed it. But this time better. All right, so why do I keep doing that? N equals 2, script. Run the script again because I screwed up. N equals 3, run the script. Yay, n is 3. N equals 4, run the script. Boo. Right, so everything works in Matlab just as well. Can open it in here, same file. So this is syntax for if and else if. Yeah, okay. I guess that's mainly what I wanted to explain for MATLAB. We can do a while loop, so why not? End. Oh yeah, this is a good opportunity to do something else. So if I say I equals 1, and then I have, let's say, while I less than or equal to 10, let's space that out nicer. What am I going to do? Let's do display I. So you can use display with a variable, and it should print it on the screen. I'm going to save that. This is going to be my while script. This is not part of the homework. I'm just explaining how while loops work. So I save it. Let's run this script. You'll see that there's a problem. So I can, remember there's multiple ways to do it. I can start typing it at the command prompt like that. Or I could also just click the run button up here. But I'll just type it, while script, run. Now, notice over here, you can see the command window scrolling. Why is it scrolling? Because this is an infinite loop, right? I is 1, and I say while I is less than 10, display I. Well, where does the value of I ever get changed? It doesn't. This is a while loop, not a for loop. I does not change automatically. So now I've just started an infinite loop that I need to stop. So if you look up here, there are ways to stop it. You'll have to look for it on the screen. Hold on a second. There's pause. I can also click on here and probably I won't pause. I thought there was a little red button, like an emergency quit. I don't see it, but I can pause it. But if I pause it, look what happens. I paused it, it paused, but then I've got a weird prompt here. And you use that if you want to pause the running of a function so that you can try to debug it, okay? So I'm if all I was trying to do was stop this script, I didn't do it in a good way because it's paused in the debugger. If I click quit debugging, it's going to start running again. Wait, is it? Oh no, it actually just stopped. Oh, come on. Well, I guess that's good. Runs, and hit pause, quit debugging. Okay. So that's one way to do it. Another way to stop it from running, I'll change this to like 4 so you can see it's different. Run. All right, so now it's running again, infinite loop. Another thing you can do is if you click, or not click, if you press Control C, if you click on the command window first, so you're in the command window, and then you hit Control C, operation terminated by user, right? So that was, I clicked Control C. I clicked Control C. I didn't click, I typed it. That's what I did. Type Control C to stop execution. So if you ever make an infinite loop, that's the way you can do it. Press the buttons or just Control C. I almost always Control C because that's how you do it at a lot of different command line languages. Okay, so that's what I do automatically. So how would I fix this so that it only ran the 10 times that I wanted it to? Well, I would want to display I and then increment I. So now if I run it, it should just go 1 through 10. And yes, it does, right? Works perfect. Now, here's the thing that you need to know. So this code ran here, but you guys took Java, so you're going to be tempted to type this, I++, right? But let me do that. Run. Error. Does not run. This syntax here does not work in Matlab. If I go over to Octave, let me open the while script. Here it is. Let me try to run it in Octave. While script. Works in Octave. Okay, so this plus plus here, Octave understands it, but Matlab doesn't. And that's one of the rare differences between Octave and Matlab. To be on the safe side, don't use it, right? You can just type out I equals I plus 1 when you need that. Save. Run. Run. You know what I'm going to do? I'm going to change it back here. I'm going to get rid of that equals I plus 1. Save. I'm going to run it. We're going back to the infinite loop. Run. Now I'm at the editor here, so I have to click command window to see what's happening. Now, notice that you don't actually see anything on your screen right now. It's not scrolling the way Matlab did. And that's because Octave, by default, will not display stuff on the screen until after the script terminates. So if I hit Control C, which I'll do, then I'm going to stop it, and then you're going to see all those ones that it should have displayed on the screen. See? Hit Control C, stopped, get all these ones, and it actually will let me, you can't see it, but how it says less, forward, back, it actually wants me to scroll through all of them. So when you see this, you probably just want to press Q. Get back to the command prompt there. So that was an infinite loop, but you didn't see it being an infinite loop. If I run it again, it's running. Again, I don't see a good way to stop it from here. Guess I can go run. Well, I will Control C it. And then press Q again, and we're back. Okay, so try to remember that for stopping an infinite loop there. Let's go back to Matlab. Save it again. Okay, so again, in a while loop, you have to increment your counters or not automatically. You have to do it yourself, just like you would in Java. So that's not actually any different. Let's get back to the actual programming assignment here. So you go through this. I'm not going to do these, right? You create this problem 2. Oh, actually, right. Do we have that? Do we have problem 2? Did we do problem 2? Oh yeah, we did. We did problem 2 last time, right? There it is. So we did problem 2. Problem 3. Problem 3 said we were supposed to take this code, but in problem 3, did we do that? Yeah, we did. We have problem 3. Problem 4. Yeah, problem 4 is the one that you actually have to write yourself, right? So this says, here's code that does a running total. Problem 4, I'm going to copy this. Where's problem 4? So I have to try to find this. I can see at the top it says running total. That's how I'll find it over here. So I'm going to scroll down. It's hard to see. I see it right here, running total. So this was a script that is not problem 4. This script is not problem 4. Do it in Octave. So I'm going to go File, New Script, paste it, save. I'm going to save this as problem 4, but I have to edit it. Problem4.m, save. So what does this do? So we put S. S is going to be for sum. S is 0. I goes 1 through 10, and it adds it one by one. So like the first time through, it's doing this. I'll type it right here. Right, the first time through this for loop, S is 0, I is 1. So it goes S equals S plus I, but that's 0 because that's what S is, plus 1 because that's what I is. And then, of course, the result is 1. But then the next time through the for loop, it's going to go S equals S, which is 1 from last time, and then plus I, which is 2. And so the next time through, it's going to be 3. And then the next time through the loop, S equals 3. That's the previous S value, plus the I value, which is also going to be 3. So it'll be 6, and so on. And so this is keeping a running total. I is going from 1 to 10, and this we're adding I to the previous total as we go. And so the final result here from this code is going to be 1 plus 2 plus 3 plus 4 plus 5. It's going to go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, which I believe is 55. Save it. So if I come here and I run problem 4, then I get that. Now, be careful though. First of all, this is not the program we're supposed to run. Second of all, this still has the bad way to do the printf, right? Technically, what I have to do is I have to go like, I need a string variable. So I can go like, we're already using S, so let's not use that. So like st for string or something. Change that to a sprintf, and then I should do display st. We'll do str. That's how it should be done. So I should fix that and upload it for you guys. Run. So now that runs in Matlab too. You got to do that 2-line thing to display it on the screen. Okay. Now that was not actually problem 4, right? Because problem 4 says, where's the PDF? Problem 4 actually says we want to add 1 cubed, 2 cubed, 3 cubed, up to 50 cubed. This adds 1 through 10, not 1 through 50, first of all. So if you want to make this add up 1 through 50, you would just change this right here, right? 50. Now it'll add 1 through 50. Run. Okay, that's 1275. That's not the answer though, right? Because what was the code actually supposed to do? If you read it, it says, where are we? We want 1 cubed, 2 cubed, 3 cubed. So where am I going to cube the i's basically? Well, I is what's going 1 through 50, so you just need to put a cube right here. And it does not need to be that one, right? Remember what the dot does. The dot does element by element powers. But in this for loop, I is just a number. It's 1, and then it's 2, and then it's 3. But it's only one number at a time. So you do not need the dot there. But also, it doesn't hurt to have the dot there. So either way will work on this code. So if I save this, run, it run. Okay. So this right here is actually what my answer is, that problem. So I'm just copying it. So it says create a script that adds up the cube of the numbers, use a for loop like I showed, we just did. Make sure you actually report what the sum turns out to be here in your PDF, right? So right down here, I can type according to my code, all caps because I'm angry and not because I hit it by accident. Recompile. Well, actually, that's wrong, right? 1 cubed to 50 cubed. I should have changed that. Save. Terrible things have happened. Oh, yeah, because it's trying to interpret this as like. So this is something that you're not supposed to really have to know. But if I want to print math symbols, I need to put dollar signs around that. Otherwise, you get weird things happening there. Okay, so I did problem 4. Should change my code though. 1 cubed, 50 cubed. There, run. All right, that looks a little nicer. So there we go. I did problem 4. Well, let's check we did problem 4 actually. 5 points for your M file. Okay, I made the M file. 5 points for copy pasting your code into the PDF. Look at that. I didn't do that, right? 5 points for your results. So here's my results. So I have my result. I have my M file. That's what I made in Matlab. I did not do this yet. I did not put the code into the PDF. Okay. So what you're going to need to do to get your code into the PDF is just the way that I have the code here is how you get your code in here. So it says, according to my code, the sum of numbers 1 cubed to 10 cubed is this. Well, how am I going to get my code in here? Well, the way you do it is look at this block right here, right? I typed code. Here it is. So what you need is a line that says begin LST listing. I just say list listing. There's no I there, but that's just how I pronounce it. So begin list listing. It ends with end list listing, and then you just put your MATLAB code in between. And that's what makes the nice looking box over here. So if I want to put my code into this PDF, I'm just going to copy this block, put it down here. Oops. Hit compile. You'll see it didn't work out so perfectly nicely. There's a couple problems with it. First of all, the box goes from one page to the next page. That's not great. And also, there's a big blank page at the end. And the reason for that is because of this new page. So I use those whenever I want to, that's how you can kind of control when LaTeX separates pages. So the easiest way to fix this, make it look a little better, is take this new page and move it up, maybe above my answer here. So maybe I'll just put it right here above that box, then I'll say my code for prob 4. I still have caps lock on. My code for prob 4. Recompile. So don't be afraid to do things like move like a new page line around, okay? All right, so now I have my code in here, except that that's not my code, right? That's the same as this. So I want my actual code here. So I'm going to go over to Matlab or Octave, take my code, copy it, and I will just put it in here. Recompile it, and then there's my code. Okay, and so that's how you get your code into the PDF. You just want to copy paste it between a line that says begin list listing and end list listing. And that is why we have that M code file there. That's what is doing that nice syntax highlighting for us. Now, Could you do this all in Microsoft Word? Yes, you could, but it's a real pain to get code formatted nicely in Microsoft Word. And so I really recommend that you do LaTeX, okay, like I am. All right, so that's problem 4. So let's look at problem 5. 15 points for answering the 3 questions at the end of this. Okay, 15 points there. 5 points for including the cubulator.m. What is cubulator.m? Oh, I got a function right there. What are the 3 questions at the end? Oh, okay. What file name do I need to save the function with? Right? It tells me actually. What result do I get if I run this? Okay, so I need to report those results. And why is it okay to have my input called A, right? Referring to these 2 lines previously. Why is it okay to have my input called A when the input variable is called X in the M file, right? So up here it's called X, but here it's called A. And we talked about that last time, but you need to save the file name for the function. Sorry, the file name needs to be the same as the function name. So it would need to be called cubulator.m. What result do I get if I create the function and run it? Well, do it yourself. And then it says, why is it okay to have input called A when it's called X in the function name? That's because this X is an internal local variable to the function, right? So outside, it doesn't matter, right? If I'm in Matlab or Octave, if I type in sine 5, right? If there's a sine function somewhere, it's going to have a local variable. Well, what's the name of the local variable? We don't know and we don't care, right? You can call sine 5. You don't have to know what the variable is called inside the function. That's up to the function, right? We just need to put a 5 into the function and the function needs to call it whatever. So we can make A135 and then run cubulator and there's no problem there. Okay, so you answered those questions, 3 of them for 15 points. And then you also need to include cubulator.m, which we need to make. Very simple function though, it's just this line. Find it. Well, hard to find in the code, isn't it? Oh, it's right here? No, here it is. With an Octave, no. Editor, file, new. I'm gonna say new script. Well, no, I'll say new function to show you. If you use Octave and you click new function, uh, cube, u, later. Oh, it didn't do what I thought it was gonna do. Oh, because it already existed. Hold on, let me delete this. Delete the file. Yes. Close. Okay. New. Nope, that's not what I wanted. New function. Cube, u, later. Okay. Yeah, so it does all this nonsense up here where it like gives you an open source license and it puts your name in and dates and a sample function header and all that stuff. We don't need any of that. This is my function. Okay, we'll talk more about what you can include in a function in the next assignment, but this is all I need here. So there's my function and I'll save it. So there it is. Okay, code's already there, so you don't need to include it. You can do this yourself. This is writing your own function, and this is your function. So I tell you how to start it like this, and you're just going to be putting this function in here in appropriate MATLAB-y type syntax. Also notice that, again, you have a big blank page here. That's because I changed the length of the file here previously, and now there's a new page line that's making me have a new page way early. So like if I look down below this, I could probably find the offending new page right here. Just delete that, save it. Yeah, and then now I get rid of the blank page. So whenever you see that happen, like a big blank section, it's probably because I typed a new page uh, in order to keep the formatting looking nice. But after you add stuff, the formatting's not nice anymore. So there you go. Okay, so okay, and then we ended with plotting a graphic here, which I talked about in the previous lecture. So what I'm going to do now is I'm going to pretend that I'm done with the assignment, okay? So if I'm done with the assignment and I want to turn it in, what am I going to turn in? So what do? Complete the assignment and turn in your work in the following way. Number one, attach your PDF. You need PDF. Your M files. You can zip them up if you want to, or attach them one by one. That's fine. Don't zip your PDF. It's actually fine if the PDF is in the zip file, but your PDF needs to be separate from the zip file as well. Yeah, it really will make my life easier if you follow these instructions. So let's try to do it, okay? So let's say I'm ready to turn this in, and what will I do? So first of all, let me go to Octave here. So I was doing this all in some folder. You can see what folder is my current folder here, here. Hopefully you made a folder for each assignment. You don't want everything in one place. Easiest thing to do is copy that. And you can open a file explorer. I'll just do this. I'm already in there, but like, let's say I'm in my C drive and I don't know where anything is. And then I can click here, paste that, and that's how I can get to this folder where all my stuff is. Now, what did I say you need to do? You need all of your M files and you need the PDF. So where's the PDF? Well, guess what? I'm going to delete the old PDFs here. I don't have a PDF. I don't have a PDF in here. Why not? Because in Overleaf, I've been editing this, right? I've been writing this document. I never saved it, right? Put my name on it, by the way. Don't forget to put your name on it. Name. You can put the date, whatever. Okay, so there's my assignment, okay? Well, you need to save this file somewhere. So if you look up here, once you're done, you click download PDF. That's how you're going to do it. I do not want the text file. So like over here, program homework 0.1 tech, I don't want that. I don't want this. I want the final PDF that looks nice. That's what I want, okay? So you click download PDF, save it. I'm saving it to that same folder. Save. So it's called sample programming one. Save. So I have sample programming one. So when you get ready to turn your stuff in, here's how I would do it. I'm just going to select all of the files that I want to turn in. So that this PDF, what else? Problem 4.m, problem 3.m. I don't need two problem 2s. One of them is fine. Cubulator, I think you're supposed to turn in. I'm just holding down the control button and I'm selecting them all. If you hold down the control button, you can select multiple files. Hopefully you've done stuff like that before. So I just selected all the files that I think I want to turn in. Double check that I'm not missing any, right? Because you're doing your own. Like I don't know if I finished the assignment, but you should obviously. Once you have them all selected, I'm going to right click, and I have 7-zip installed, so I can compress it into a zip file, but you might not have that. So just assuming you're just using Windows, I'm going to click send to compressed zip folder. So send to compressed zipped folder. And it'll ask me what I want to save it as, and you could save it however you want, just programming one, whatever you want. Your name, programming one, just anything. I'll do like Greg, programming one. Okay, so that's my zip file, okay? Don't just save it, make sure you can tell the difference between your zip file and the original zip file, right? You want to turn in the finished homework assignment, not the beginning homework assignment. So in that zip file, right, I just have those files. Okay, now, once I have that zip file, how am I going to turn it in? Well, I go to the assignment, right? So let's just say I'm on the home page. I want to turn it in. So I click Programming 1 here, Submit up here, Submit Assignment, and it's only going to let me, I don't know if it says it, but it's only going to let me turn in, I believe, PDFs and zip files. So what I would do is I would click Choose File. What are we doing here? Let's go there. I need, and this is where it's important. So what does it say? Attach your PDF of your write-up. Do that first. So sample programming 1, I'm going to click on that. Open. Okay. Add another file. And then I'm going to add my zip file second. So I add my PDF from Overleaf first, and then my zip file second. And then when I'm done, I'm just going to hit submit. Okay, and then that's it. So what it says here actually, PDF, IM, and zip. So I could have attached all of the IM files separately instead of a zip file. So like if I go to resubmit, I could have choose a file, PDF first, and then I could have gone choose file, cubulator, choose file, problem 2, another file, choose file, problem 3, another file, choose file, problem 4, right? I could have done that all separately. It doesn't really matter. When you're done, click submit. And I actually have like multiple submissions now. Now you can do that as many times as you need to. Try to do it right the first time, but it doesn't really matter. So there you go. Main thing is that your sample, or your not sample, your programming, your PDF should be first. And the reason I want that, I'll show you why. When you're me and you're grading, read grade. Oh, don't read. Don't read. This is somebody's PDF. Oh, it looks just like my PDF. It's okay. Let's go to test student, right? So if you put the PDF first, then when I go to the assignment, it shows me the PDF first, and that makes it 100 times easier to grade because I don't have to unzip files and I don't have to download stuff and that kind of thing. So that's why you do the PDF first, so you can make it easy on me trying to grade this. Okay, and that's how you submit it. And you can see the due date, which is like 11:59 on Friday. Okay, feel free to come to office hours and get help with this for anything you need help with. I'd be happy to explain any of this stuff again. Okay. Okay, so I think that's it for this video. Oops. Gonna stop recording. That's killing my eyes. So I'm gonna stop recording and upload this for you. And yeah, good luck. Get started early. Takes longer than you think to make everything right.